in this video we are going to learn, as you can see, about gallstone. So firstly we are going to discuss briefly about different types of gallstones and their composition, but our focus is going to be mainly on pathogenesis of cholesterol gallstones. And as this video is for beginners, so I'm going to get into basic details to make the concept clear, but I am assuring you that I won't leave any advanced aspect of this topic uncovered either. So let's get started. Cholelithiasis. Now, this is a rather difficult term to pronounce, but the meaning is quite simpler. It just means the presence of stones in the gallbladder. Now, gallstones are of two types: cholesterol gallstones and pigmented gallstones. Now, depending upon the percentage and content of cholesterol, the cholesterol gallstones are further classified into two: pure cholesterol gallstones and mixed cholesterol gallstones. Similarly, depending upon the appearance and color of it, the pigmented gallstones are of two types as well: the black pigmented gallstones and the brown pigmented gallstones. Now we'll see the composition of each one of these in detail. First of all, about pure cholesterol gallstones. Hmm. This is how it looks like. I must admit it's not as gross and repulsive sight as I had expected it to be. Now this is the case of multiple pure cholesterol gallstones. The stones are yellowish to greenish in color, and I've also shown what we get when we zoom in one of these stones. Now let's see the composition. As it is pure cholesterol gallstones, so it mainly consists of cholesterol, about 90%, and this cholesterol is in the form of cholesterol monohydrate crystals. Now, what are these cholesterol monohydrate crystals? Well, we'll learn this in a minute when we'll learn the pathogenesis of cholesterol gallstones. Now, the remaining 10% of it also contains calcium bilirubinate and calcium carbonate. And yes, these pure cholesterol gallstones are radiolucent, that is, you can't really detect them in X-rays. Now, after pure cholesterol gallstones, the next type is mixed cholesterol gallstones. Now, let's listen what this mixed cholesterol gallstone has to say. My composition is pretty much same as that of pure cholesterol stone, just the percentage of cholesterol varies. Okay. So is it more or less than pure cholesterol gallstones? Well, it is obviously less. The pure cholesterol gallstones are known as pure for a reason, that is, its high cholesterol content. Makes sense. Now, what's the difference? Well, the pure stones have 90% cholesterol, whereas the mixed stones have their cholesterol content anything ranging from 60 to 89%, except that these two types of stones are almost the same. This means the mixed stones are also going to have calcium bilirubinate and calcium carbonate as their other constituents. Now the pigmented gallstones. Here we have brown and black pigmented gallstones, as you can very well see by their colors. Now both of these black and brown pigmented gallstones have less than 20% of cholesterol, and the similarity ends here itself. That is to say that they don't have much in common. That means they have plenty of differences, so it would be really interesting to see the comparison. Now the war begins between these two types of pigmented stones. Well, not really. It's us who have to fight against both of these stones. Now let's see the difference. Based on location, the black pigmented stones are common in India, whereas the brown pigmented stones are found in complete Asia. Now, based on a precise location, yes, we are going from the country and continent right into the organ itself. So, it's very, very precise location. So, black pigmented stones are found in gallbladder, whereas brown pigmented stones can be detected in bile duct. And we do have a specific term for that, which is cholelithiasis, which actually means the presence of stones in the bile duct, in contrast with Cholelithiasis, which is the presence of stones in the gallbladder. Now, based on calcium salts, black pigmented stones have calcium carbonate and calcium phosphate, whereas brown pigmented stone has calcium palmitate. Now, based on whether you can see them in X-rays or not, black pigmented stones are 50 to 75% radiopaque, whereas that is you can see them in X-rays, whereas brown pigmented stones are radiolucent, generally radiolucent, that is they cannot be detected in X-rays. And the most important difference between the two is something I've not listed here. It is that brown pigmented stones are found in infected bile, most commonly bacterial infected bile, whereas black pigmented stones are found in sterile bile, that is bile which is free from any kind of infection. So what really causes it if not infection? Well, there are factors such as chronic extravascular hemolysis and the things like that. We'll see that when we'll cover the pathogenesis of pigmented stones in the next video. So far, it has been smooth sailing. I just had to state some facts and show you some relevant pics, but it's pathogenesis where lots of explaining have to be done. So let's get right into it. Pathogenesis of cholesterol gallstones can be best explained with the help of four processes. These are cholesterol supersaturation, accelerated nucleation and crystallization, gallbladder hypomotility, and growth to stone-sized aggregate. Note that all of these four processes are not in any specific order as they take place simultaneously. So let's study each one of them one by one. First of all, cholesterol supersaturation. There are some things we need to know before we jump right into our supersaturation concept. For example, we need to be familiar with the concept of solubility. Solubility is ability of the solute molecules to get dissolved in a solvent. Now it could have been a bit more elaborated, but that would just complicate things. The basic idea is what I've just stated. Now don't let this big dissolve word term haunt you. Let me break it in simpler terms for you. Particles of solute will dissolve if they are more attracted to solvent particles than to each other. So that means their intermolecular bonds will break and they will start forming bond with solvent particles. And this is what which results in solvation or dissolving. Here we can see that happening. The solute molecules or the red molecules are breaking their bonds, the bonds among themselves, and instead forming bonds with the blue or the solvent particles. Now let's take example of a solution which has most common and universal solvent, that is water, and the solute molecule is NaCl. Now Na plus of NaCl will get surrounded by O minus of H2O, and similarly the Cl minus of NaCl will get surrounded and form bond with H plus of the H2O, and the end result would be that this NaCl solute will be soluble in the solution which has solvent water as a solvent. So it was very easy for NaCl because it was able to give out the Na plus and Cl minus ions because it was ionic and polar. So these ionic and polar molecules have another name which is hydrophilic molecules. So the bottom line is, in order to be soluble in a solution that has water as a solvent, the solute molecules should be hydrophilic. Now, one of the other thing you need to know is about bile. Bile is a fluid that is made and released by the liver and stored in the gallbladder. Now, just to get you a real feel, this is a bile which is drained from gallbladder of chicken. And those who wanted to see the human specimen, please don't get disheartened because I've got it for you. This is a bile which is refluxed into stomach. Now we have used the term reflux because reflux means flow of fluid other than its normal direction. Now ideally the bile should be flowing from the gallbladder to the duodenum, but it is flowing into the stomach. That's why we have used the term reflux here. So this is what bile is. Now let's consider bile as a solution. Now, like any other solution, it will have two components, solvent and solute. Now bile has water as its solvent. Yes, bile is composed of 97% of water, but that's about the hepatic bile, that is the bile present in liver. But the bile present in gallbladder is concentrated to a great extent because about 90% of water is reabsorbed in it. Apart from storage of bile, one of the most important functions of gallbladder is to concentrate it. But in spite of this concentrated version, the bile present in gallbladder still has water as its solvent molecule. Now after the solvent, let's see the solute component of the bile. So the bile has bile acids, for example cholic acid and quinodeoxycholic acid, and it also has phospholipids such as lecithin, and it has got cholesterol as well as its solute component. Now for those who want to see all the solute molecules a bit more closely, this is cholic acid, which is an example of bile acid component of bile. This is quinodeoxycholic acid, which is another example of bile acid component of bile. This is lecithin, which is an example of phospholipid, which is component of bile. And lastly, this is cholesterol, which is also a component of bile solute. So this unsterified cholesterol is also known as free cholesterol. It is an active form as opposed to cholesterol ester, which is a storage form. Let me recall the major takeaway from our discussion regarding solubility was, in order to be soluble in a solution that has water as a solvent, the solute molecules should be hydrophilic. Now bile happens to be one such solution who has water as a solvent, but the solute molecules of the bile like bile acids, lecithins and cholesterols, are they really hydrophilic? Well, the bile acids and lecithins have some portions which are hydrophilic, but the cholesterol molecules are almost nearly entirely hydrophobic. So, the $1,000,000 question is, how do these cholesterol molecules remain soluble in a bile solution which has water as a solvent if they are hydrophobic? And the answer is this magical mycel. This structure does the trick. It has cholesterol in the center, the yellow part in the middle, which is surrounded by phospholipids and bile acids in such a way that the lipophilic portion are in center, while the hydrophilic portions are oriented at periphery, so that only hydrophilic part gets to interact with and form bond with polar solvent water molecules, while the whole hydrophobic core remains hidden. In this way, all the three solute molecules, in spite of not being completely hydrophilic, manage to become soluble in bile. Water really gets fooled by these three molecules. You might have heard about three idiots, and now you know three genius. Yes, I call them three genius: bile acids, lecithins, and cholesterol. We just saw how phospholipids and bile acids help cholesterol to be soluble in a bile. This tendency of bile acids and phospholipids or lecithin to help cholesterol to remain soluble in a bile solution is known as solubilizing capacity of the bile. After going through all those basic concepts, you are eligible and super ready to learn the new concept of supersaturation of cholesterol. Supersaturation of cholesterol is a condition in which cholesterol concentration or content of bile exceeds the solubilizing capacity of bile. So basically, in case of supersaturation, bile has increased number of cholesterol molecules, so much so that phospholipids and bile acids can no longer help them to be soluble in bile. Now the causes. As we said, there is increased number of cholesterol molecules. Now the cholesterol present in bile have not appeared by magic. The liver secretes or excretes it. So it's known as biliary cholesterol. So if there is increase in biliary cholesterol secretion, that can result in increased number of cholesterol molecules. So that can be one cause. Now, it the other cause is it might be possible that there's just not enough bile acids and lecithins around to help cholesterol. So there can be decrease in bile acids or lecithin. The effect of decrease in lecithin is not much pronounced, so we'll just see the decrease in bile acid factor. So we'll learn both of these one by one. So first of all, increase biliary cholesterol secretion. Now, increase in biliary cholesterol secretion can be seen in case of obesity. So, obesity is characterized by excessive hepatic secretions of cholesterol. That's a known fact. And it can also be seen because of cholesterol-rich diet and high caloric diet, such as butter, honey, etc. Now, in order to emphasize on high caloric diet or high cholesterol diet factor, I am presenting you this. Here you can see as an evidence, diet is indeed a source of cholesterol. So what you eat really matters. Increased biliary cholesterol secretion continued. So it can be due to certain drugs such as clofibrate. Now clofibrate is a drug which lowers cholesterol level in blood. So how does it do it? Well, by excreting those cholesterol into bile and feces. So clofibrate, in this way clofibrate results in increased biliary cholesterol secretion. Similarly, pregnancy. Biliary cholesterol in bile increases gradually from first to third trimester of pregnancy. Oral contraceptive pills. Oral contraceptive usage increase biliary cholesterol secretion, and whereas they don't have any significant influence on bile acid and phospholipid secretion. Now, rapid weight loss. Obesity increases biliary cholesterol secretion, that we've already seen, but so does rapid weight loss. So when you don't eat for a longer period of time, or when you lose weight quickly, your liver start releasing extra cholesterol into bile. So here is something your liver wants to say: neither obesity nor starvation, no extreme conditions, please. Have a balanced year. Some serious advice there. Now the last one in the chain, that is the last factor, increase activity of HMG-CoA reductase. Now these colorful ribbons or springs that you are watching right now, it's actually HMG-CoA reductase enzyme. For those who didn't like the abbreviated form, the exaggerated form is 3-hydroxy-3-methyl-glycerol coenzyme A reductase. Now enough of naming, let's talk about some serious business. What does it actually do? It is a rate limiting enzyme for mevalonate pathway. Now what is it, mevalonate pathway? Well, it is the pathway which synthesizes cholesterol. And what does rate limiting enzyme mean? Well, rate limiting enzyme means it's a key enzyme that determines the rate or pace of the reaction. So how fast or slow the reaction will proceed. So if the activity, it controls the overall pace of the reaction. So if its activity is increased, it will lead to increase in the rate of the complete reaction. So it will result in acceleration in production or synthesis of cholesterol. Basically, increase biliary cholesterol secretion. After increase in biliary cholesterol secretion, the other factor for cholesterol supersaturation was decrease in bile acid. So it can be due to Crohn's disease. Now, Crohn's disease is an inflammatory bowel disease. It causes inflammation of digestive tract and most importantly ileum. So how is it relevant to decrease in bile acid? Well, for this you need to know bile acid enter hepatic circulation. So there it goes. Bile acids are produced in liver, then it is stored in gallbladder. From there, it then travels to small intestine, and from the terminal ileum, they are effectively reabsorbed into the blood. And then by portal venous circulation, there is reuptake of these bile acids by liver, and then liver can re-secrete it into bile. So this is how it goes. From the liver, the bile acid is stored in the gallbladder, obviously as a constituent of bile. Then from gallbladder, it travels to small intestine, and from the terminal ileum, it is reabsorbed into blood, and with the help of portal venous circulation, there is reuptake of these bile acids by liver, and then the liver can re-secrete it in the bile. This is how enterohepatic circulation of bile acid takes place. So this is what goes wrong in case of Crohn's disease. There is inflammation of the ileum, so the bile acids are not effectively reabsorbed. So in other terms, there is malabsorption of bile acids, which results in a decrease in reuptake of these bile acids by liver, which eventually leads to decrease in secretion of these bile acids by liver. Now, after learning about both the causes of supersaturation, we can conclude it as supersaturation end product is excess of cholesterol that is not soluble in bile. So how does it lead to formation of gallstone? So for this we have to proceed towards our next step or the next process of cholesterol gallstone formation, that is accelerated nucleation and crystallization. Accelerated nucleation and crystallization. First of all, what is this nucleation? Nucleation is a formation of a new structure through self-assembly or self-organization. So what is the new structure which is being formed here? The excess of cholesterol which we got from supersaturation is in the form of a unilaminar cholesterol vesicles. These unilaminar cholesterol vesicles fuse to form multilaminar cholesterol vesicles which self-organize or nucleate to give cholesterol monohydrate crystals. So that was the process of nucleation and crystallization. Here we can see the unilaminar vesicles, the multilaminar vesicles, the cholesterol monohydrate crystals and its better view. We've also got a real image of cholesterol monohydrate crystals that I really want to show you. Here it is, the glowing part. This is cholesterol monohydrate crystal seen in polarizing microscopy. Accelerated nucleation means the speeding up of the process of nucleation, and this accelerated nucleation results in more and more of the cholesterol monohydrate crystals formation. Now there are two types of factors which are responsible for this accelerated nucleation. Pronucleating factors, these are factors that are in support or that promotes the process of nucleation. And the other one is antinucleating factors. These are against the process of pronucleation. So in order for the speeding up of nucleation, pronucleation factors should be in excess, whereas there should be deficiency of antinucleating factors. Pronucleating factors, one example of it is mucin. Mucin is high molecular weight glycoprotein which is secreted by epithelium of gallbladder and biliary duct. So how does it really promote the process of nucleation? Well, this orange knots that you can see here is hydrophobic part of mucin. Being hydrophobic, it is binding site for cholesterol vesicles. So it provides a platform for cholesterol unilaminar vesicles to come closer, and then they can fuse to form multilaminar vesicles. So in this way it helps in nucleation process. Biliary calcium, it's another example of pronucleating factor. So it contributes in vesicle aggregation or fusion. So in this way it accelerates the process of nucleation. Here you can see how two unilaminar vesicles are fusing to form the larger vesicle. Now antinucleating factors. Less is known about antinucleating factors as compared to pronucleating factors. One of the examples are apolipoproteins A1 and A2. Now what are these apolipoproteins? These are actually proteins that bind to lipid to give lipoprotein. So apolipoprotein when gets combined with lipid gives lipoprotein. Now for the visual satisfaction, this is apolipoprotein A1 and this is the gene coding for apolipoprotein A2. We are mentioning apolipoprotein A1 as anti-nucleating factor. So it should oppose the process of nucleation. So how does it do it? Well, to promote the process of nucleation, the factors promoted the vesicle aggregation, right? So in the same way, to oppose the process of nucleation, the factors should oppose the vesicle aggregation. There is phospholipase C, which is a pronucleating factor or enzyme that I forgot to mention. This provides hydrophobic binding sites for cholesterol vesicles in the same way as mucin does. Now what apolipoproteins A1 do, they shield or cover the hydrophobic binding sites for cholesterol vesicles so that they cannot come and bind to that sites or thereby preventing their fusion as well. So in this way it inhibits the cholesterol vesicle aggregation or the process of nucleation. Note that apolipoproteins A1 and A2 are present in normal bile as well, but it is when there is decrease in these apolipoproteins which result in accelerated nucleation and eventually gallstone formation. So far we have seen in nucleation, firstly there is cholesterol unilaminar vesicle, then cholesterol multilaminar vesicles, and lastly cholesterol monohydrate crystal. So accelerated nucleation will result in more and more of these cholesterol monohydrate crystals. So the story is not over yet. We are studying pathogenesis of cholesterol gallstones. So from these cholesterol crystals we have to go up until cholesterol stones. For this we need to learn the next concept of gallbladder hypomotility. Gallbladder hypomotility. Now hypo means decrease, so decrease in motility. So in order to understand this hypomotility, first we need to know what is normal motility of gallbladder. So normally when we eat, especially fatty foods, the stomach releases CCK, that is cholecystokinin. Now this CCK causes contraction of gallbladder and squeeze out the bile stored in it into the duodenum. So motility refers to emptying of the gallbladder or contraction of the gallbladder which results in emptying of bile from the gallbladder. But in case of hypomotility, there is decrease in contraction of gallbladder, hence the proper emptying of bile cannot take place. So the most of the bile remains stuck in the gallbladder. Now this gives more time for aggregation of cholesterol monohydrate crystals which are present in the bile as a result of nucleation. This aggregation of cholesterol monohydrate crystals result in the formation of biliary sludge. So that leads our discussion to the concept of biliary sludge. Biliary sludge is formed when there is gallbladder hypomotility or complete stoppage of gallbladder movement, that is gallbladder stasis, and in this case the bile becomes more thick and viscous. Now we just now saw biliary sludge is nothing but aggregation of cholesterol monohydrate crystals. So this is what particulate solid is, and apart from these crystals, more or less it is just those crystals, but We do have some other constituents such as mucus and some calcium bilirubinate and salts in small percentages as well. So let's see some pics of it. This is biliary sludge. I've also got pic from ultrasound sonography. So the arrows are pointing towards the biliary sludge. Have a look at these pics for your better understanding. Biliary microlithiasis. Now this is the final nail in the coffin. Note that it is different from testicular microlithiasis. So it is microlithiasis is formation of microstone. So biliary sludge that we just saw can be resolved or removed, or it can progress to form microstone. Now microstones are small gallstones which have got diameter less than 3 millimeter. So it's just the size, otherwise it's almost the same as gallstone. Some even consider this microlithiasis same as biliary sludge. Now these small dots that you are watching right now in this ultrasound sonography, these are microstones. Now I just can't wait to go to the next slide. So finally we are here, gallstone. So the microstone increases in size by adding more and more cholesterol molecules and some other constituent to it, and finally forms complete full-fledged gallstone. So just to revise the complete pathogenesis of cholesterol gallstones, firstly, because of supersaturation, we got some insoluble cholesterol molecules in the form of unilamina vesicles. Then by the process of nucleation, these unilamina vesicles fuse to form multilamina vesicles and finally monohydrate crystals. Now these monohydrate crystals, because of gallbladder hypomotility, formed biliary sludge. Now after that, because of process of microlithiasis, these biliary sludge gave rise to microstone, and just by simply adding some cholesterol molecules to it, this microstone finally formed complete cholesterol stones, complete cholesterol gallstones. So that was it. Now let's just see some pics of these complete gallstones, cholesterol gallstones. So this is a single cholesterol gallstone. You can see resting in gallbladder. The circular portion, the spherical structure here. This is another pic of single isolated cholesterol gallstone. This is a bit neat than the previous pic. This is the pic I have chosen because I wanted to show you multiple cholesterol gallstone case as well. So here you can see 4 of these stones. Now can you just tell me, okay, are you able to recall that which kind of cholesterol gallstones can it be, pure or mixed? Well, it is mixed cholesterol gallstones, because we have seen that pure cholesterol gallstones are really difficult to detect. So just to finish with a realistic touch, this is an opened gallbladder with this is the gallbladder which has been opened, and there is one single cholesterol gallstone in it. Now this is greenish in color. It can be yellowish or something in between, like yellowish greenish in color, but this particular one is greenish in color. Now this brings us to the end of this video, and in the next video inshallah we'll discuss about the pathogenesis of pigmented stones. So stay tuned and thanks for watching and listening.